Hi, I'm back and ready to talk about section 5.2, binomial probabilities. Since it starts with the word bi, that means there's two possibilities. And in this section, they're called success and failure. So perhaps you've got two possibilities. It's going to rain today or it's not going to rain today. Now, which do you call success? One person might call it success if it rains. One person might call it success if it doesn't rain. But it's going to be obvious in the question what's meant to be success. So you'll be given a probability of a success, like there's a 5% chance that it's going to rain today. Oh, sorry, I meant to say 3%. There's a 3% chance that it's going to rain today. So in this situation, since that's what we were given, then that's going to be the success. And change the 3% to a decimal 0.03, and we call that lowercase p. Then failure would be the opposite. In this case, it's not going to rain today. And if there's a 3% chance for rain, that means a 97% chance that it's not going to rain. And then that's called lowercase q, 0.97 in place of the 97%. So suppose you look out over the next 7 days, what's the probability it's going to rain on exactly 2 days? That's the type of question we're going to be answering in this section. But first, we need to go over some notation. So as I just showed you, the lowercase p, that's going to be the probability of one success. So the probability that it would rain on 1 day is a 3% chance. The q is the probability of failure, so you just need to go 1 minus 0.03 and you'd get 0.97. Then in that last example, I said, what about the next 7 days? So that would be n, the number of trials. And then I said, what's the chances that it's going to rain exactly 2 of those days? So that would be x equals 2. And then finally, calculate the probability. Now I looked at the homework on my stat lab and I noticed that they really emphasized the following. So for a binomial experiment, the following 4 requirements need to be met. Number 1, there's a fixed number of trials. So in other words, if you're going to talk about the next 7 days, you can't halfway through the problem change that and say, oh, I meant to say the next 30 days. No, if you're talking about a week, n equals 7, and it's fixed. That's not supposed to happen. Number 2, the trials must be independent. What this means is, if it rains 1 day, so if it rains on Wednesday, that does not affect what's going to happen on Friday. So Wednesday and Friday, they're independent. Or for example, if a couple is planning to have 3 children, the gender of their first child has no effect on the gender of their second child, so the trials are independent. Number 3, each trial must have all outcomes classified in 2 categories called success and failure. Well, since it's a binomial situation, yeah, that's it, two categories, success and failure. And this p right here remains the same for all of the trials. So when I did the little example of there's a 3% chance of rain, well, if we were in January, that's probably going to be different than if we're in July. So you can't just apply January's probability to January's possibility of rain. Okay, so it's a fact that 80% of my Math 13 students go on to pass the class. Suppose we choose 4 of them. So the p, the chance of success, is 80% or 0.80. This is n, a sample size of 4 people. Find the probability exactly 3 of them will pass, because 3 out of 4 would be 75%, so it would be a little more than that, but we can't have 3.2 people, so go with 3 of them. So what we could do is use from the previous chapter the multiplication rule. So this is passing, 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 and then not passing would be 20%. So you could just multiply them. Now the only problem with that is that assumes that it was the fourth person that failed the class. The first three people passed the class. But maybe it was the third person where the point 20 goes, or maybe it was so. We need to consider all the cases. That the point 20 was last, the point 20 was the third person, the point 20 could be the second person, or it could be the first person, and all the others are at point 80. So in other words, we have, in all of these cases, we have point 80 raised to the 3 times a point 20 to the 1. And then we have 4 of these. So if you put that in a calculator and multiply it, you'll get 41%. Now this 4 right here comes from the combinations. Remember in the previous chapter, the counting, combinations, and permutations? So this would be combinations. You might be thinking right now, I thought combinations was when order doesn't matter. Well, what I'm saying with this combination that says you have 4 people, so here's the 4 people. Choose one of them to be the one that doesn't pass the class. Then for these other 3 point 80s, does the order matter? So if I switch the point 80s and I take this one right here and then I move it to the front and I take this one and I move it over here, it's the same thing. So in a way, order doesn't matter. So that little 4 right there, rather than having to write out all of the cases, you can just put n combination x. And that is the binomial formula. So you put the combinations in front, and then p is the probability of success, x is how many successes are being asked for, and if there's n people total, then there's going to be n minus x that don't succeed. So this exponent and this exponent will always have to add up to the n, which in this case was 4 people. All right, then on to the next example, 84%, so that's going to be p equals 0.84. 84% of high school, that's supposed to say high school students admit to cheating on a test at least once. Suppose that you've got 20 high school students. What's the probability exactly 7 of them have cheated at least once, or at least would admit to it? So first, write down the information. So this is the chance of success, finding somebody that admits to cheating. So that's a 0.4. Q always equals 1 minus P, so that's going to be a 0.16. This is 20 high school students, so that's the number of trials. And then it's saying x equals exactly 17. So you could do the formula and it would look like this. And you would get 24.1%. But you could also use the calculator. Now it's a little bit different from because usually we use the stat button right there, but this is under distributions. Can you see it? So you have to put second distributions. So that's what I did. You can see my fat finger right there going second distributions. And then you have to scroll down to the 11th one in the list, which is called binomial probability distribution function, or binomial PDF. And then hit enter. It's going to ask for the number of trials, 20. The P is 0.84. You don't have to tell it the Q because it can figure this part out itself. And then you have to tell it the x value is 17, and then it's going to do this formula for you. So I would recommend that you don't even use this formula, you use the calculator with the binomial PDF. At the bottom, that will paste it onto the screen, and then you need to hit enter. And then it's going to give the same answer, 0.241, or if you change that to a percent, 24.1%. Okay, now make it a little more challenging. There's 20 questions on a multiple choice test. There's 4 answers to choose from on each question. And you're just going to guess. So the chances you guess right are going to be 1 out of 4. Find the probability you get at least 15 right. So since there's 4 answers and you're guessing, the chances of getting it right is 1 in 4. That would be 0.25. The chances you get it wrong, 0.75. N equals 20, and then this one is saying x is bigger than or equal to 15. So there's 2 ways to do this. You could do the binomial formula when x equals 15, 16, 17, 18, 19, and 20. Do the binomial formula 6 times, and then add up those answers. But there's another way to do it, and that is use the complement. So the probability that x is bigger than or equal to 15 is equal to 1 minus its complement. Now, the opposite of bigger than or equal to 15. So let's say this is saying you have at least 15 people, and then the opposite. So you don't have at least 15 people. Well, if you don't have at least 15, that means you've got 14 or less. Now, the reason for doing this step right here is because the calculator will calculate this for you when it's less than or equal. For some reason, it won't do it for bigger than or equal, so you have to do this one extra step right here. So then, what we're going to use is, still have to type in the 1 minus. Instead of binomial PDF, we're going to use binomial CDF. The C means cumulative. So it's going to go from x equals 0, 1, 2, 3, 4, 5, 6, 7, all the way up to 14, and it's going to add those up, and that's what the binomial CDF does. This is the n, 20, this is the p, 0.25, and this is this 14 right here. And that would be the answer. Now, let's take a look at the calculator. So start by putting the 1 minus, then go again to second distribution. Scroll down and make sure that you get the one that says CDF. So this is the one for less than or equal when it says C. If you put the one that says P, that would be just for equals 14, not less than or equal. So binomial CDF, you tell it the n is 20, the p is 0.25, and we've now changed this to be a 14, so make sure you put a 14 right there. When you put paste, it will then put it on the screen and hit enter. And this answer is scientific notation. So this is saying, because it's negative, it's saying take the decimal and move it 6 places to the left. Wait, that's my left. Your left would be that way. Unless you're watching this backwards, then it's that way, but I think it's that way. Anyway, it means take this decimal and move it 1 time. So that was 1 time. Now I need to move it 5 more times, which means that I would have the decimal move over and I would have 5 zeros and then the 3813. Let's see if I did it right. 1, 2, 3, 4, 5 zeros and then the 3813. So that is right.